Good to go, sir. You can start, sir.
Yes, sir. Someone need to share the screen.
You can take control, sir. Everyone can share. Are you with the laptop, sir?
Yes, sir.
Okay. So try sharing your screen, sir, or I'll try to share from my end if you not possible.
Oh, fine. Is this visible now?
Screen is visible, sir. You can proceed, sir. Sir, may I tell few words about your introduction,
Yes,
sir?
sir. Yes, sir.
Uh, there may be some deviation. Kindly excuse, sir.
No issue, sir.
Yes, sir. It is a privilege and distinct honor to introduce our guest speaker today for the session of faculty development program on green energy technologies for sustainable development. Today we are especially joined by an academician and researcher who has dedicated his career for a future of innovation. It is rare to honor with an introduction of a visionary leader who stands with the intersection of academic excellence with the global scientific impact. So, not to mention too much about him, he is currently the innovation director in Jain University, which is a deemed university, and he is widely known as Dr. APJ. Synonymous to our former president, Abdul Kalam sir. So for the past 20 years, he is not only the professor of mechanical engineering, he has contributed to the field of thermal management, nanomaterials for energy devices, and metal additive manufacturing. So apart from the regular publications of academic articles, he has contributed with excellent research background, and he has listed in the top 2% of scientists in world by the elsewhere Scopus and Stanford University, which is standing as a testament for his global relevance with respect to his research. Talking about his innovation, his favorite playing sport arena, it is his entrepreneurial spirit along with the current leaders in the Jain University, such as Dr. Chandra, who are taking up with the news breaking up on the startups and the technological advancement from the Jain University. So I think he is also mentoring the next generation of engineers and steering the Jain launchpad towards the new horizons. So it is an honor for me to welcome on behalf of our head of the department. Please give a warm welcome to Dr. Arul Prakash Joshi. Sir, you may take over the session, sir.
Yes, sir. Thank you, sir. Thank you for the wonderful introduction. It's not similar to our President Dr. Abdul Kalam. It's Arul Prakash Jyoti. In short form, people will call me as APJ, so that I still keep that. So apart from that, I'm honor and I'm proud to present a part of this FDP program. Particularly, I want to thank the coordinators, Dr. M. Selvam and Dr. S. Muthukumar. Along with, I want to thank the management of Welltech Multitech College. So I hope all of you enjoying the FDP program, particularly on green energy technologies for sustainable development. So this is many people wonder why the need of kind of talk related to green energy, because everyone run behind the electrical vehicle, and people are working on battery technology and battery thermal management, and how to increase the potential and efficiency of hybrid vehicles in this era, in this 2026. What is the purpose of talking about the green energy technologies? This is what many people wonder, and they are thinking that the entire IC engine, the engine based transportation is completely vanished, and some people who are all expert in energy, even though they talk about this automotive part and the transportation, the future transportation, still no the behind, and still depends on electrical vehicle technology. So my topic is potential and effective utilization of biofuels in IC engines, internal combustion engines, because we are in the era, we are in the situation where the electrical vehicle technology emerging in a exponential way, because the global market for electrical vehicle technology is very high. So in this era, we are going to talk about the potential and effective utilization of biofuels. Right, there is the efficiency of engine, the performance and characterization of engines. Right, still many people completed PhD in this area, alternative fuel. And alternative fuel means, if you check it with Scopus, the number of publication, particularly in any domain, particularly in mechanical engineering, particularly alternative fuel engine, right? In this, the research paper, the number of research paper is very, very high. Still people are working, still fuel publishing the landmark research articles in its journal. But some few things will help us to understand. Sir, is there any change in the slide? I have changed the second slide.
Slide is changing, sir. No issues.
Okay, fine. So my thing is, why internal combustion engine still matter? This is what the first question come to our mind. In our transportation system, if you divide or classified the Indian transport system, it's completely based on two-wheeler. 85% of our transportation system depends on two-wheeler. Only 15% depends on four-wheeler. In that, the heavy-duty transport means it's very, very less. It's anyway the major, more than 90% of Indian GDP and Indian economy depends on the distance traveled by the heavy-duty transport, particularly trucks, buses. Not only buses, particularly on trucks. So still now it's 90% depend on liquid fuels, right? Even that convergence or that transfer of IC engine or liquid fuel based into electrical fuel based, the conversion happening only in the two-wheeler segment. In the most cases, it's happening in the four-wheeler segment, in the SUV vehicle range. In the heavy-duty transport, when we talk about trucks, the percentage is nearly about 1%. That is what our thing. So that we need to work on the fuel side, right? Still, the heavy duty transport depends on the liquid fuel. The percentage is nearly less than 10%, right? So here I want to discuss a few statistics here. So nearly 75 to 80% of vehicles in India are two-wheelers, making them the backbone of daily commuting. It's affordable, fuel efficient, and ideal for traffic conditions. But that 80% in this, only 10% to 15% converted into EV. Then the second segment is four-wheeler culture, the cars and the SUVs. It's only no covered 15 to 18% of the vehicles, right? It's depends on the urbanization and income, the heavy vehicles. Particularly when we talk about the Indian economy in GDP, anyway the contribution is only 5% from the total segment. But then when we talk about the economy, when we talk about the GDP, the contribution from the heavy vehicle is very very high compared to four-wheeler or two-wheelers. Right now, then one more thing, wheel to that is the efficiency part. Everybody knows the government, particularly Indian government, stopped the subsidy because that's that expected conversion rate, right, from a engine to electric vehicle, it's drastically improved in the last 5 years because of the subsidy. So just government stopped the subsidy. Behind that, so many history is there because of the battery technology, because of the battery thermal management system, so we can call it as BTMS. So these factors affected the entire conversion rate. Not only the Indian conversion rate depends on subsidy, the global market behind the battery technology affected the conversion rate. So somewhat the conversion rate slowed down, but even there is negligible amount of conversion happening in the heavy vehicle segment. So this is what we are going to talk about, the energy density and refueling time, the existing fuel infrastructure. So when we talk about the energy density of the liquid fuels, refueling time, and existing fuel infrastructure, right? So it is very very difficult. As of now, I'm talking about 26 and the roadmap given by the international community up to 2040. Considering this roadmap, the refueling time, the fuel existing fuel infrastructure, then the fleet replacement timeline. So considering this, replacing heavy trucks from IC engines to EV is very very difficult. It's very difficult to achieve the target. This is what the still IC engine is matter from the heavy truck perspective. Why? Because the entire Indian economy depends on distance traveled by the heavy vehicles, right? This then now we coming to the biofuels, renewable liquid fuels from biomass. I understand that many topics covered in this, right? 3 days, we are in the third day. So solar energy, wind energy, and energy storage system, and smart grid and energy management, green hydrogen, right? Then additive manufacturing, the research trends, then the commercialization. With these aspects, this FDP covers all aspects of green technology. Today, I'm going to talk about the biofuels and the potential opportunity, and then the barriers and advantages, disadvantages behind that. We know that all of us know about the definition for the biofuel. Biofuel are renewable fuels derived from biological feedstocks such as agricultural crops, waste biomass, algae, and organic residues. Here, the only thing is from the global warming perspective, from the ecosystem perspective, when we talk about to maintain the proper ecosystem, this is the alternative way. Still, it is the effective way to achieve the green environment. So classification of biofuels. One is first generation fuel. It's completely food based. Ethanol, derived from sugarcane, corn, and biodiesel. It's derived from vegetable oils. The second one is the second generation fuel. It is cellulose based ethanol and biomass to liquid fuels. The third generation is completely algae based. The advanced level is hydro treated vegetable oils and sustainable aviation fuel. These two comes under the classification of biofuels. So we know that how the biofuel will impact the IC engine, particularly when we talk about SA engine and CA engine, right? So as we discussed, bioethanol in spark ignition engine. Only thing is the advantages completely depends on combustion characteristics. It improves the anti-knock performance, enables higher compression ratio and faster flame propagation and reduced carbon monoxide and hydrocarbon emissions. Right. So only thing is the fuel properties, which is the influence and cause for this performance is ethanols, bioethanol particularly. The octane number is very high, and the high oxygen content influence this kind of efficient performance. So the brake thermal efficiency increases and fuel consumption increases. It also reduces the particulate matter emissions. So when we talk about petrol engine, so bioethanol influence in all category, combustion category, performance category, right? Here the biodiesel. So when we talk about the diesel engine, already we discussed in the classification of biofuels, this first generation food based, the vegetable oils, particularly soybean, palm, jatropha, then waste cooking oil, animal fats. These are all the feedstock for biodiesel. If anything happens, please any one of you intimate me. Right. So in between, I'm in the fourth slide. I think the slide title is biodiesel, renewable substitute for diesel engine. If it is not visible or anything happen, some network interruption may be possible. So if you identify any disruption, please intimate it to me. So the biodiesel feedstock is completely vegetable oils, particularly jatropha. Many researchers worked in this area. Particularly, if you type jatropha in the Scopus, you can identify minimum 10,000 research paper related to it. But people are working more in this because of the cetane number, the high cetane number, and the oxygen content is also comparatively high, 10 to 12% thin. Then one more thing is the viscosity is slightly higher than the diesel. Right, the lower calorific value nearly about 37 to 40 megajoule per kg. Right. So when we talk about diesel, the lower calorific value is nearly about 43 megajoule per kg. Here, that we can consider the advantage. Better lubricant is possible with biodiesel. This is what people identified. It's improved combustion and reduced smoke and particulate matter. Many people worked in this area. So comparable brake thermal efficiency to diesel. The performance analysis, when we talk about brake thermal efficiency, many researchers achieved so comparable performance. A significant reduction in CO, hydrocarbon and particulate matter reported in this segment. Here the biogas and biomethane. So here the feedstock is agricultural waste, municipal solid waste and sewage sludge. That the figure shows the potential waste energy to useful energy conversion is possible when we look into the biogas, when we achieve some technological development in the biomethane and biogas, the gaseous biofuels. You can easily identify many commercial vehicles running with the blend of biodiesel in India. Particularly the problem, the barrier involved in this kind of fuel usage is the supply chain. We need to increase the biofuel or biomethane availability to support or to encourage the people to use this. One way is waste to energy pathway. Another way is it's very low soot formation. It's reduced CO2 emission is very less. So that from the ecosystem point of view, to mitigate global warming potential, we need to look into this bio gas and biomethane process. So here it can be used in SI engine and compatible with CNG engine platforms. Particularly performance and emission characteristics. Here, the methane slip remains a concern. We need to consider about the combustion parameters. When we talk about the combustion parameters, it's high knock resistance happen with this biogas. It's a completely cleaner combustion. This is advanced biofuels. So because just I want to introduce the variety of biofuels and classification of biofuels from the first generation to second generation to advanced generation. So the purpose is to encourage, motivate the participant to do research on this area, because everyone talk about AI and AI/ML related research. But AI is a tool. Anyone can learn AI, and when we implement or incorporate AI with the engine research or combustion research, means you have a potential opportunity in the industry sector, particularly whatever the category, EV or engine based. You have a opportunity to work, to do research when we integrate AI with engine research. This is what happening. So to understand biodiesel, this will work. Which kind of bio fuel will work with the spark ignition engine, which kind of biofuel will work with the diesel, and the potential opportunity behind biogas. This is advanced biofuels. So the fuel quality is very high. It is better engine compatibility, the lower life cycle emissions. Here we can use algae-based biofuels, but then the advantage for algae-based biofuel is its high oil yield per hectare. Then is hydro-treated vegetable oil. Right. In this, the superior cold flow properties identified in the hydro-treated vegetable oil. Then some more sustainable aviation fuel is available. This is biomass to. It is biomass to liquid fuels. The technical advantage is higher cetane number, lower sulfur content, reduced particulate emissions, no major modification required. So this is what with advanced biofuels. The comparative physical and chemical properties of conventional and biofuels, particularly ethanol. Ethanol used in the spark ignition engine, petrol engine, there the observation is high octane, low energy density. With the biodiesel, it's again higher cetane, oxygenated, cleaner combustion. HVO, it comes under advanced biofuel. It is the energy content available in the HVO is completely equal to diesel. Right. Then you can the lower heating value. When we compare the lower heating value, all of us we know the heating value. It is 42 to 43 megajoule per kg. For gasoline, it is 43 to 44, but for ethanol, it is 26 to 27. In the advanced HVO hydro-treated oil, in this vegetable oil, in this the lower the heating value is completely equal to the diesel. The viscosity is very high with advanced biofuel compared to gasoline and ethanol. So the advantage of advanced biofuel, we can call it as next generation engine. It's compatible with the next generation engine. The properties, particularly lower heating value or the viscosity or the oxygen content. When we compare these advanced biofuels with the diesel, almost the energy content and the oxygen content and the viscosity are similar to the diesel. This is the best advantage of this advanced thing. The combustion behavior, particularly when we talk about the engine, we need to talk about the combustion part, performance part, emission part. So we will discuss briefly about the combustion part, performance part, and emission part when we use biofuel with diesel and petrol. So the key combustion parameter is ignition delay. So when we consider biodiesel and ethanol, so the biodiesel shorter ignition delay, the ethanol longer ignition delay. The heat release rate, when we talk about the heat releasing rate, so we can higher peak heat release rate for ethanol blends observed in the spark ignition engine. Then flame temperature is the main thing which will affect the combustion parameter. The flame temperature may increase NOx formation in CA engines when we discuss about diesel engine. Then the spray automation in diesel engine, higher viscosity of biodiesel influence the spray automation, larger the droplet size may occur. Then the performance, particularly its improved knock resistance. Here, the performance characteristics, brake thermal efficiency and brake specific fuel consumption, power output. So when we add the blend of the biodiesel will improve the slight increase with brake thermal efficiency observed. Then the brake specific fuel consumption increases with higher ethanol content. The power output, particularly that the slight reduction of power output observed at higher blends. It's all based on the research papers, literature. So till now, the researchers observed these kind of performance characteristics when they blend the biodiesel, biofuel with the conventional liquid fuels. When we talk about the emission trends, the CO on the particularly carbon monoxide and hydrocarbon reduces when we use biofuel on the particular matter, and this will result. This is the major emission parameters, the emission behavior of biofuel in SA engine and CA engines. Here, the major component is carbon monoxide and unburnt hydrocarbons, nitrogen oxide, and particulate matter. Particularly the CA engines, all three, carbon monoxide, hydrocarbons, and smoke, particulate matter, all decreases. When we talk about SA engines, the particulate matter, hydrocarbon, carbon monoxide, the decreasing trend was observed, but the slight aldehydes, increase in aldehydes observed in this thing. So the overall impact, when we observe the overall impact, the significant reduction in particulate emission and improved urban air quality potential, the life cycle carbon dioxide reduction happened when we discuss this biofuel. So biofuel, as of now, we discussed about the introduction to the biofuel and the classification of biofuel and how it react with petrol engine and diesel engine and how it affects the economy. What is the purpose of biofuel still in this current scenario when we talk about AI technology, AI enabled technology with engine? Here, some more aspects we need to understand when we do research or when we identify the potential opportunity in the biofuel. So the biofuel as a driver of rural economy and circular sustainability. The only thing, first thing is the agricultural integration, utilization of sugarcane, corn, and oil seeds, non-edible crops, particularly, for example, jatropha on marginal land, the crop residue. This is the here the usage of these things when we introduce the latest technology with biofuel, so automatically the effects will be observed in the agricultural field, because here our conversion is waste to energy pathway. We know as a metropolitan citizens how the municipal waste handled. Here, when many Chennai-based people witness how the municipal waste accumulated somewhere near in the South Chennai and North Chennai. When we use proper technology for this kind of conversion or this kind of blend usage of biofuel with the conventional fuel, definitely it will reflect the waste to energy pathway. We can efficiently handle and the municipal solid waste, then used cooking oil, then the agricultural residues. It will automatically reflect in the rural employment and income diversification. Particularly when we talk about the circular economy model, the biomass to fuel to energy, that will reflect into CO2 emissions and control, then the biomass. This reduces the landfill burden and enhances the energy security. This is what automatically the national level benefits happen. It will reduce the crude oil import and strengthen rural energy in excess, support for sustainable development goals. So biofuel establishes a circular energy ecosystem that simultaneously enhances rural livelihoods, waste management, and national energy security. So the technology involvement and the research enhancement and new idea related to the biofuel usage will definitely reflect in the rural economy and waste management and national energy security. So the techno-economic feasibility and life cycle carbon analysis. The first one is the production cost. The production cost nearly the total the feedstock cost 40 to 70%. It can be when we use the biofuel, the feedstock cost nearly we can drastically reduce the feedstock cost nearly about 40 to 70%, right? Then the scale of production and hydrogen requirement, we need to stick with these things. So life cycle assessment, well to wheel approach, right? Here some electrical vehicle technology people, they can argue well to wheel percentage, the energy conversion. When we talk about the liquid fuel, particularly petrol or diesel, right? Liquid fuel to the fuel economy or the brake thermal efficiency, this energy conversion, whatever the energy available with the fuel, particularly petrol or diesel, when we convert that into the wheel, right? When we convert into the kilometer travel, the conversion rate is somewhat less when we compare to electrical vehicle technology. So the petrol or diesel into electrical energy, then electrical energy into mileage or the transportation coverage. This conversion rate, when we introduce electrical energy in between to petrol and the brake thermal efficiency, somewhat the efficiency increases. This conversion rate is very difficult to understand. You just read some more article to well to wheel concept. Well to wheel conversion rate is high with the electrical vehicle technology, because the 100% energy conversion is possible with electrical energy, but it is only 30%, 30 to 35% with diesel or petrol. This is the challenging aspect. But when you blend with biofuel, then the usage of biofuel will increase the conversion rate, and it will also compete with electric vehicle technology. Then the carbon intensity, it's a conventional diesel gasoline. The high life cycle CO2 absorbed, and biodiesel and ethanol moderate reduction happens. But with advanced biofuels, the 88 up to 80% reduction happens with carbon intensity. The challenges, so feedstock availability limitations and competing land use and water footprint, market price volatility. With this, we need to understand the techno-economic viability, waste derived feedstock and integrated biorefineries, policy incentives. We need to discuss about these things. Then this is very important aspect, sustainability assessment and environmental trade-off. Is this visible to you all? Sustainability assessment slide. Am I audible to you all?
Yes, sir.
That PPT I am asking, sir. Which PPT is visible to you? Sustainability or
Sustainability assessment and environmental trade-off, sir. Hello?
Sir, thank you for the response, because from one side I'm talking about biofuel and advanced technology and the research trend, but other side I don't know how many of you responding and how many of you listening to this lecture. First point, sustainability means whenever you write a proposal or the research article, if you include the sustainable aspect, definitely you will get some kind of, your acceptance rate is little higher, even with research proposal or paper or whatever it is. Whatever your research, whatever your identification, whatever your observation, try to link it with sustainable factor, SDG goals. Definitely it will get a high impact compared to other, because the true environmental benefit of biofuels depends on responsible feedstock and life cycle emission management and integrated sustainability planning. This is very important thing, because carbon, when we talk about carbon neutrality, biofuels operate within a short carbon cycle. The net emission depends on land use and fertilizer application, processing energy source and waste-based biofuels. The highest carbon reduction potential is possible with waste-based biofuels. Then the second thing is land use. First generation biofuels, the risk of forestation, because whenever we talk about biofuel, completely the environmentalist, they will come and fight with us. So whenever the technology improvement happens with biofuel technology particularly, it affects the impact is deforestation. Right. So we discussed about the advanced biofuel. The energy content is equal to diesel, and the other parameters. Everything is the physical, thermal parameters. It's equivalent to the diesel. Means when we introduce higher technology, when we integrate AI and ML with this technology, it may be equivalent and more than the diesel. Then what will happen? All people will, they depends on biofuel. So if many people depends on biofuel, automatically the risk of deforestation happen. So this is what we need to consider this. Right. So the second and third generation fuel reduce land competition. So water footprint and air quality benefits. The significant reduction in particulate matter, lower sulfur emissions, improved urban air quality potential. So this is the technology barriers. So till now we discussed about the classification of biofuel, how the impact with petrol and diesel engine, and how the performance analysis, combustion analysis happen. But when we talk about the technical barriers, So first is coal flow properties. The risk of fuel line blockage, it is happen because it requires coal flow improvers or blending. Otherwise, there is a possibility of blockage in the fuel line. We need to consider when we talk about the coal flow properties, because now with the help of technology we can come out of this barrier. Still people are working on to identify the potential pathway to come out of these technical barriers. But as a researchers, we need to understand where exactly technological influence is required. This is what very important, right? So first is coal flow properties. The second one, lower energy density. So lower energy density means ethanol and biodiesel have lower calorific value. As we discussed, in the advanced biofuel, the energy content is equivalent to diesel. But when we compare to ethanol and biodiesel, the energy content is comparatively low with diesel and petrol. So what will happen? It increased fuel consumption and reduce vehicle range in higher blends. Then the third one is fuel stability and oxidation, right? So sometimes some researchers reported the gum formation and polymerization and the reduced long-term storage stability. So if you keep the fuel for a long time, the energy content, there will be a change of parameters happened. This some researchers observed fuel stability and oxidation barriers along with biofuel. Then the material ethanol, particularly with ethanol, the corrosion of rubber seals and metallic components. Right? When we use methanol, this is material aspects. Now people are using composite material even in the engine segment, and wherever you go nowadays, composite material, the usage of composite material is very high. But anyway, we need to consider when we use methanol, it corrode with rubber seals, it react with metallic components and rubbers. Biodiesel, its deposit formation in injectors happen, right? Then you know how the deposit affects. When some deposit accumulated in the injectors, it will affect the complete efficiency of the system. The fuel system modification may be required for higher blends. Then NOx emission tendency, right? Advanced injection control or EGR is required. So while biofuels offer combustion advantages, their practical deployment requires mitigation of coal flow, material compatibility, and emission control challenges. Because some advantages are there, still there is some technical barriers associated with biofuel. We need to understand there is coal flow property and energy content and fuel stability, material compatibility. With this understanding, we can go, because somewhere some researchers reported when we go for higher blend, we can observe the higher thermal efficiency and higher higher thermal efficiency as well as the lower emission rate. So when we select or when we propose some kind of proportion, right, we need to consider how it will affect the stability, material compatibility in the longer run. That is very important. Here, the future research directions. The future research direction means first thing is low temperature combustion strategies, because it's a controlled combustion, right? That is very important. We need to stick with the combustion parameters, the complete combustion, right? For that, the low temperature combustion is very important. First thing we need to understand that. Then hydrogen enriched biofuel combustion. Here, this is biodiesel hydrogen enrichment in CA engines or enhanced flame speed and cleaner combustion. is possible with hydrogen enriched biofuel combustion. Whenever the future research, if you consider the sustainability part and the future research, future possibility and future scope, there is possibility of the success acceptance rate. The acceptance rate is very high. So advanced injection and spray engineering, so ultra high pressure injection system, multi-pulse injection strategies, spray automation and optimization for higher velocity, higher viscosity fields. Then one more thing is AI-based combustion optimization, because real-time engine calibration using machine learning, adaptive engine timing control, predictive emission modeling. This is very important. The next generation of biofuel research integrates advanced combustion modes, hydrogen enrichment, and AI-driven optimization to achieve ultra-clean and efficient IC engine operation. So the sustainable feedstock development, it's algae-based high-yield lipid production, waste biomass conversion, integrated bio refinery concepts. It's very important, because why we need to discuss about this future research direction, that is very important, because as we know, I hope the majority of these participant depends on stick with mechanical department or core branches. This is what my understanding, because particularly mechanical department organizes this FDP. Right. The majority in any engineering college, the core branch shares only 30% of the total strength. Less than 30%. Strictly speaking, many colleges only 10% relate. 10% falls this category. Remaining 90% is A and CSE based. Even in the future research, whenever we talk about any kind of mechanical system, not only engine, right? So the integration of AI is very important. If you know any kind of AI model which will help to improve the engine performance or combustion performance, or any kind of management, thermal management system or lubricant management system or safety management system, if you introduce any kind of AI, right, there is potential opportunity to get acceptance from the research paper perspective. The same way, there is opportunity to attract funding from the different agency. This is possible. If you work with biofuel, it falls under clean energy or clean environment category, and AI, it falls under future emerging technology category. Then automatically you will get at least research stipend from the DST or ANRF. That is possible. Finally, it's a biofuels as a strategic pathway for IC engine decarbonization. The key takeaway is internal combustion engine will remain relevant in heavy duty and long transport sector, because the complete economy depends on distance traveled by the heavy duty engine. Keep it in this mind. Replacing engine or automotive IC engine by electric vehicle means it's happening only in the two-wheeler segment, because the 85% of our Indian transport falls under two-wheeler segment, right? Only 15% stick with this four-wheeler, and in that only 5% is heavy duty. But heavy duty completely depends on diesel, petrol, fossil fuels, and the Indian economy and other GDP, everything depends on this. So the major shift in this area may not happen near future, immediate future. It may happen after 10 years or after 20 years. Some miracle happens in the battery technology. So some kind of we are running out of material shortage with battery technology. So some research finding will happen. Definitely it will happen in the battery technology. Up to that, we need to stick with the conventional fuel, so that the biofuels offer immediate decarbonization potential, because the conventional fuel affects the global warming, the greenhouse emission. It's the majority part is, the major part is from the transportation only. So that the urgent need of work with understanding the biofuel and work with the technology related biofuel. The understanding the technology behind the biofuel will help us. So the advanced biofuels, there people are talking about the energy content associated with advanced biofuels. It's very high. The life cycle sustainability, the engine optimization and calibration are key to maximizing efficiency and emission benefits. So with this, I conclude my talk. If you have any queries, we will discuss about that. Any queries, sir?
So one question, sir.
Yes, sir. Yes, sir. Please.
So what is the difference between bioethane and biomethane, sir?
Bioethane and biomethane.
Yes, sir.
So that is, it's a derivation of fuels only. One thing, sir. 1 second. Sir, sorry, I don't know. Actually, I will check and update to you, sir.
Okay, thank you, sir. Right,
Yes, sir.
Thank you, sir.
So, technical challenges, I think I covered some technical challenges. So, one question related to what are the main technical challenges to effective utilization? Sir, I think the technical barrier I discussed, particularly the some properties, cold flow properties related. The stability and the compatibility with materials, so conversion efficiency. This is what we discussed. And one more question is, what about the cost of biofuel when compared to diesel? The cost analysis, some as of now, the biofuel cost is no little higher than the diesel, but when we compare to right, that is specific fuel consumption, right? The cost wise, it may be equitable with diesel. So biofuels increase NOx emission. No, sir. Actually, biofuel, what we know discussed, the researchers particularly as of now, the researcher reported some slight variation in the NOx emissions. But in the practical case, we need to understand that the biofuel means the everything. It depends on the percentage of blend. If you increase the blend, when you add more proportionate, it will reflect in the emissions. Other than that, some less than 10% or less up to 50%, there will not be a perfect study on this. But people recommended biofuel based on the. This is what the standard experimental observation reported as of now. But one thing I want to clarify that whenever we are introducing alternate fuel, many reporters, many researchers, they are testing the efficiency of the fuel with the old engine, right? Whatever the engine available in the laboratory. But the fuel is new. The fuel is completely new. The fuel property is completely new. But testing the same fuel in the old engine, the means it may be before 2010, or it may be older than 2000, right? It may not give a proper result to them. So whenever I request all the researchers, whenever you propose the new fuel, please test it in the advanced engine. Then only we will get the results somewhat relevant to the requirement. Right? As of now, there is no numerical value based result is very less. Only brake thermal efficiency, the slight increase in brake thermal efficiency observed, and the decrease in emission was observed. This is what the results.
I think there is no more question from the audience end. If there is any questions also, I may redirect to you, sir.
Yes, sir. Actually, I'm additive. I'm thermal engineer. I'm working in the heat transfer and heat transfer related work. I'm not that much expert in the IC engine, and right. So from fuel part, some. No, theoretically, we know about some biofuel and the potential opportunity is there. I am working in the waste energy to waste to energy conversion area, so that sir requested me to take this topic. Particularly, some many researchers are there. They have an in-depth knowledge about IC engine and that part. So my area is waste energy to useful energy. This is what my area. So if you have any queries related to this, and what is the potential opportunity of introducing metal additive manufacturing in this area, waste to useful energy, I'm ready to collaborate with anybody, and I'm ready to clear or learn any new things related to it. So in-depth understanding about IC engines means many experts available in this FDP. So please discuss fuel part, in-depth fuel part analysis and IC engine analysis. Please discuss with some experts related to it.
Yes, sir. Yesterday's session we covered with Dr. Raghu from Sri Venkateswara College. He covered
yes, sir.
about,
Yes, sir. Yes, sir. He is expert in the fuel preparation and property, experimental part. And
yes, sir. So we have many more sessions also to discuss on this fuel property, replacement of diesel, how to get blended biodiesel and all these things. I think subsequent session, the audience will get new light on it. And
Yes.
your part is very importantly on the innovation related to waste recollection, waste management, or waste to wealth. Sir, my personal question is like, are you people really interested to put their hands really onto this waste to wealth kind of investments in terms of startups and business?
Yes, sir, definitely, sir. Actually, you have our government, particularly MHRD and ministry they have a separate ministry for this. So, central government is ready to fund any kind of new proposal related to waste energy management. So, waste management, particularly waste into energy conversion. We have a potential opportunity in this area. If we do any kind of research in this area, it is very easy to attract funding and papers. You can easily publish papers with high impact factor. But many startups are particularly with on the TANCAM, Tamil Nadu government initiation with TIDCO. So more than 10,000 industries associated with TIDCO. In that, 10% is almost working on this area, particularly waste management area.
Yes.
But waste into energy means in the fuel side, very few are working. But we need to encourage our researchers to work on this area.
Definitely, sir. Your thoughtful ideas and thoughtful reflections on your research side, they should be inspiring the upcoming researchers, scholars currently working to put their direction into this waste and really contribute to the national development, sir. So it's a very engaging session. People asked the question and you also answered very beautifully. We should be very thankful for your engagement during the session. And we will expect many more sessions like this from you, sir.
Thank you, sir. Thank you very much, sir.
Thank you very much, sir.
Thank you.
So with this, with your permission, may I close this particular session, sir?
Yes, sir. Please, sir.
Yes,
Thank
sir.
you.
Thank you. Thank you very much, sir.
Thank you,
sir.
Thank you.
sir. So audience are requested to stay in the session. So please stay in the session. So we will not cut this telecast. Our session is not now continuing actually. If you are interested, you can keep engaged till 4 p.m. because we have two more people, one coming from Kalasalingam College of Engineering, Dr. Gaudaman, who is Associate Professor there in the Department of Automobile Engineering. He will join shortly in another 10 minutes. And later on, we have also called in for a joint discussion with Dr. Balu from Bharat Institute of Higher Education, East Tambaram. So he is also ready to give you a treat on what is going to be the next scenario about sustainable development. So keep connected, sir. Anyone who are not, aware about this subsequent sessions, please see this message in the I will post it right now. Any questions you have, kindly post it in the chat box itself right now when you are engaging in this session. As we have told, our guest Gaudaman will join exactly at 2:30. I have messaged him. So please be in the session. So I just put the message in the chat box there. Kindly follow that shortly.